Hello, everyone. Welcome to today's Phlebotomy webinar on an introduction to cost of quality in the laboratory. This is Heidi Zunker, an Education Program Manager for Mayo Clinic Laboratories. Our presenter today is Mohammed Mustafa. Mohammed is a Senior Principal Systems Engineer for the Department of Laboratory Medicine and Pathology at Mayo Clinic in Rochester, Minnesota. Just a couple of things to remind everyone before we begin today. There will be a question and answer session at the end of the program. You can submit questions online via the chat function, or following the presentation, phone lines can be unmuted to ask a question. Today's program is being recorded and will be posted to our website in a few weeks. And now I'll turn the phone over to our presenter.
Good morning. My name is Mohammed Mustafa, and we'll be going through our topic today, which is basic introduction to cost of quality. First things first, I have to make a disclosure here. I don't have any current relevant financial relationship or any off-label usage as far as this webinar today is concerned. So with that out of the way, let's get into our topic of the day. So our learning objectives for today is to give a brief, I would say, basic introduction to the concept of cost of quality. What is it? What are the main components of the concept of cost of quality, and have a very simplistic calculation of cost of poor quality. So we picked this topic of cost of quality. So the question that we need to ask ourselves is, why does it matter? Why do we care about cost of quality? As you can see, we are in the business of providing lab results, providing other lab services. So whatever we can do to maintain our bottom line is very important to us, because that is money that we can use to improve the quality of our service. If we are spending a lot of money in a wasteful way, then we're not going to have that money to provide services that are needed by our providers as well as our patients. So some of the things that cost of quality impacts are patient care. If we are spending a lot of money in a wasteful way, not providing the right results at the right time, having to do a lot of rework in our processes, then this is not a good patient care, because the providers are not going to receive the results on time to do their diagnosis. Or if we send wrong results, then the providers have the wrong results to do wrong diagnosis. So this is all have direct impact on patient care. What about the bottom line or the finances? Cost of poor quality also have a direct impact on our finances, because if you look at our margin, the margin is the difference between the revenue, that's the income, the money that we get, minus the expenses, the money that we have to spend to provide a service. So if we're spending a lot of money in fixing problems, that goes into our expenditure. So our margin is always going to shrink. If our margin shrinks, then we don't have the money to do other innovative services or come up with new ideas, new tests that our patients can benefit from. What about the staff? Employees also have, if we have a lot of issues with poor services, poor quality in our processes, employees also suffer, because it leads to burnout, it leads to low morale. Why does that happen? Because if I'm an employee, I'm a tech in a lab, and I'm spending most of my time redoing work that needs to be done right in the first place, that is not something that I'll be interested in. So that leads to the low morale as well as burnout, because instead of thinking of getting the results out the first time, now I'm spending most of my time redoing or fixing issues that happened before. So this is not also good for employees. So this also affects our delivery of service overall, because we don't have a good process that allows us to do or deliver results right the first time. So cost of quality has a very direct impact on some of these items that you see on the screen: the patient care, the finances, employee burnout, as well as the delivery of service. So we're talking about cost of quality, so now it begs the question, what is quality? As we know, we all have different definition of what quality means. But if we look at the most simplistic one is when we say quality, that's the degree to which something meets or exceeds the expectation of a customer. So looking at this description here, this is, to me, very subjective because we're trying to look at how good something is. And anytime you have something and you ask for how good it is, it's very subjective because what is good to me might not be good to somebody else. We're measuring this against some kind of standard. The question is who is providing or who is setting the standard. So this is a very subjective description because we're saying measuring or to degree at which something meets or exceeds a customer's expectation. And we're also talking about this is defined by the customer. So like I said, what is good or high quality for one person is not the same for another person. So in this case, how do you satisfy these different customer expectations? So what we need to do is look at how can you have a quality definition that is more objective. Objective in such a way that everybody can agree to it. So if you look at the industry, which laboratory is one of them, we tend to define quality as a process. And this process ensures that customers receive the products free from defects and meet their needs. So now if you look at this second definition, now we're trying to quantify and measure this quality that we're talking about. Because now with this definition, you can ask your customers, what is it that you're going to measure me against? So now we can start looking at, okay, is it success rate? Is it error rate? Is it a range of goals that I need to meet? So now we're trying to put measurement. We're trying to quantify. So now it's more objective. So now if you come back and say, okay, I promise to deliver this service to you at this goal, now we can measure against the goal. So the whole idea here is when we talk about quality, we have to make sure that it's quantifiable, it's measurable. And so we can monitor and say we either meeting the goal or we're not meeting the goal. If we're not meeting the goal, then it's an opportunity for us to do continuous improvement to figure out how we can fix these issues. So now let's get back to our topic of cost of quality. So the question is, what is cost of quality? As you can see on the screen, cost of quality is the sum of two components, which is the cost of good quality and the cost of poor quality. And what we mean by cost of good quality versus cost of poor quality. So anytime you spend money to achieve quality service, then we can say that is money that you are investing in your lab to make sure that you deliver good service. So that goes under the cost of good quality because you're spending the money proactively to make sure that you are delivering good quality. Anytime you have to spend money, on the other hand, to fix problems, then that is goes under the cost of poor quality because the error already occurred. Now I'm spending money to fix that. So if you look at this equation, at a minimum, you want to eliminate that cost of poor quality. Because if you can eliminate the cost of poor quality, then at least you can have, this goes back to your finance where you're not spending a lot of money in your expenditure. So your margin can grow. So the whole idea of this cost of quality is to make sure that first you are investing money to make sure, and we'll see some of this definition in future slides. But first, you have to make sure that you are investing money in your program or in your lab to assure that you are getting good product out of the door. But we know, of course, we do have quality issues sometimes, so you have to spend money to fix that. That is the undesirable part. That is the part that we don't want to spend money in fixing problems. Okay, so now let's look at the whole components of the cost of quality. So if you look at the cost of quality as a top hierarchy, we already saw the previous slide talked about cost of good quality versus cost of poor quality. And we try to define what this are. Remember we said cost of good quality is the money that you have to proactively spend in the lab to attain good quality. And the cost of poor quality, on the other hand, is the money that you spend to fix problems, which we don't want to see. And so on the left-hand side, the cost of good quality can also be broken down into two, prevention cost and appraisal cost. And we'll see the definition of those in the next slides. And the cost of poor quality also can be defined as internal failure cost versus external failure cost. And we're trying to break them down into these components. So once you start doing your calculation of cost of quality, you know what is costing you internally versus what is costing you externally, what you are spending to prevent cost, as well as what you spending in terms of appraisal cost. So if you look at the cost of poor quality, the undesirable cost that we don't want to see, we have two types, the internal failure cost as well as the external failure cost. So the internal failure cost is something that costs money that you spend to fix problems before they leave the door. So this is within the lab, you find an issue, you fix it. It's costing you money. And the external failure cost is the one that goes out the door. So now you have the results to the physician, or you have the result to the patient, you have some kind of product to the customer. This is not good because now your issues is already out the door. And most of the time it's very expensive to fix this type of, it's very expensive to fix these problems, because not only you have to, maybe if it's a test, you have to redo the test, but now you have issue with trust because your customers don't trust your results, and you have all these goodwill issues. So now let's go into the details and see what the definitions of some of these are. So we're still talking about cost of good quality, and under that we had a prevention cost. So the prevention cost, like we said, is money that you have to spend proactively, on preventing quality problems and maintaining high quality levels. So if your lab spend any money in having quality programs, like having a quality assistant, quality director, somebody who is in charge of maintaining quality, this is money that is well spent in maintaining in the prevention cost category. If your lab engages in QMS or quality management systems, you are proactively doing something to prevent issues from happening within your lab. If your lab is involved in continuous improvement, then you are also doing proactively things to help you to resolve issues within the lab. Any institution that does quality education, training programs, if you have new employees, or it can be continuous education to make sure that people are, competent with the work they do, this is proactively preventing errors from happening, and it goes under the preventative cost. If you engage engineering to design processes that are error-proof, then you are, proactively designing processes that allows you to have high-quality products. And of course, if you have instruments within your lab, if you do preventative maintenance, you are proactively looking at issues before they happen. So by doing preventative maintenance, You are making sure that you catch issues before the instruments break. So all these preventative costs, as you can see, these are things that I would say these are managerial decisions that the lab directors, the supervisors have to come up with these programs to make sure that we have quality issue, our quality issues is under control. We are monitoring whatever quality programs that we have in the lab. So you are proactively doing things to prevent errors. That's what this preventative cost. It costs money because you have to hire people to do this. You have to hire people to write the SOPs. So these are preventative, proactively doing things to make sure that you are maintaining quality in your lab. The other cost of good quality component is what we call the appraisal cost. So in your preventative cost, you've done the proactive design of your system. So you are engaging QMS. So now now I have to supervise. How do I make sure that I'm meeting this or I'm using this SOP the right way? So this is where the appraisal cost comes in. So this is money that you spend in assessing the quality of products or services. So now I have all my programs in place. How do I know it's working? So this is where inspections come in, audits come in, peer reviews, competency assessment. How do I know my lab assistants, my techs are competent in the duties that they need to perform? Quality controls in the lab is very important. So maintaining good quality control system helps you catch issues within the lab. So these are all assessment. All these assessment or assessing your quality problems or issues goes under the appraisal cost. And we say this is a good cost because you're spending money to make sure that errors doesn't happen within your lab. So now let's look at the other component, the cost of poor quality. And we talked about the cost of poor quality as the undesirable because we don't want these things to happen. Because I'm spending money to fix errors that already happened. So with the internal failure costs, we've talked about this before. These are errors that happens within the lab. So if you have issues within the lab before they go out of the lab, you found it, you fixed it, it's costing you money, but the good thing is it's still within the lab. So examples like ordering errors, right? So if we have a provider or somebody within the lab order a wrong test, that is something that if we catch it before it leaves the lab, we can fix it, but this is somebody's time to fix it and somebody's labor to fix it. So it's costing us money to do that. Collection errors. If you mis-ID a patient, if we have to do a recollection or redraw or restick, we are repeating a process that should have been done the first time. So this is a cost that we have to try to avoid. In the processing of the specimens, if you have an aliquot errors, if you aliquot to a wrong tube, if you do you aliquot to a wrong tube, or you have some kind of centrifugation errors within your lab, that is undesirable, and we have to find a way to mitigate or reduce that. Testing errors. So when the specimen is already in the testing lab, any errors that you can get, like example that I have here is the failed QC. If you don't monitor your QC and your QC fails, that is results that cannot be trusted. It has to be revised, and this takes time to retest this whole specimens and have to issue revised reports. So these are errors that happens within the lab. It's undesirable, and we have to make sure that we can avoid them because this is we call them waste in our system that we're trying to fix. Anytime you have to fix waste, you're spending money to do that. So now let's look at the external failure cost. So the external failure cost is money that you spend to fix errors that already is out of the door, is already in the hands of the customer. So you release the result, and the result is now with the physician or with the patient, and now they found out there's an issue. So this is now out of the door. You have to fix the problem, but now also you have to deal with what we call a soft cost. I mean, you have the trust issue with the physician or with the customer. With your lab, they won't trust your results. If you have complaints, coming from outside customer, this is also an issue that we have to try to avoid, because this is also depreciating our goodwill, because customers will not trust our results. Big one, incorrect billing. Not only is illegal, but still now you have incorrect billing to a patient that is challenging this cost or this billing that you send them. So this is also an error that shouldn't have left the lab. If you issue revised reports, you send out erroneous results, or you lose the results completely. These are all issues that this is reaching the customer, and we have to try to reduce or eliminate that as much as we can. Because these are the most expensive failure costs that you encounter within any institution. If you can avoid any results or any service that you provide, it goes out to the customer. That will help with your trust. That will help with your goodwill, and that will help with your reputation. Because once you have one customer complain, the second customer complains, and now it becomes, the word out there that we don't trust the results. So it's very important that we can minimize the failure that goes out to the customer. So now let's go to how do we calculate cost of quality. And I'm focusing on the cost of poor quality here because this is more direct to the workflow. The cost of good quality, we said this is a program. So some the directors in the lab, the leadership in the lab, the management have to come up with a program to do that. But the cost of poor quality is directly associated with your production, what you do in the lab. So how do we calculate that? So before you can go into calculating the cost of poor quality within your lab, first of all you have to understand your work. So you have to understand the path of workflow. How do I get my supplies? What is the process that I need to go through to provide this result, and who the customer of this result is. So this you can do this by coming up with a process map or value stream map, because these maps allows you to see the path of workflow, what gets done at what stage in this process. You also have to understand the timings. How long does it take to perform services within this path of workflow? So you have to do some timings. Process A takes this time to do, process B takes this time to do. So you have to know all these timings within your workflow. And also you have to have some idea of quality within your system. What are you measuring? So you have to do some data collection, do some trending to see where your pain points are. So you have to understand some of the quality metrics within your lab. Apart from that, you also have to understand some production cost. What does it cost me to provide a service? Of course, you have people in the lab that work, so you have labor cost. You have to have materials and supplies, reagents, needles, other supplies you have in the lab that helps you do the work. So you have to know per unit cost, how much does it cost for the supplies that I use and materials within the lab. You also have equipment within the lab. So knowing how much equipment costs also help. It depends on the detail of analysis that you want to do. And of course, you have overhead within the lab. You have to pay, you pay for the space within the lab, you pay for the bill, the utility bills, electricity, water, and all those things. You have to know all those. But like I said, it depends on the level of details of calculation that you want to do. So by knowing all these, the path of workflow and knowing your production costs, now you can go back and say, okay, what is it specific? What is the trigger? What am I trying to do? Am I trying to figure out, so let's say I'm trending my recollection, how many patients that I provide phlebotomy service to, and how many times do I have to call back a patient for a recollection. So maybe that is the data that you're tracking, and you have set up your goal, and you're not meeting the goal. So now you're trying to calculate the cost, for not meeting this goal. Now, okay. So this slide here is just an example of a generic, typical lab workflow. So we can see the physicians will order the test, the patient will come to you if it's an outpatient, or the phlebotomist will go to the patient if it's an inpatient to do the specimen collection. Then that's when the whole process starts. So you have the pre-analytic phase where you collect the specimen, you transport the specimen, and you process the specimen. So once that pre-analytic work is done, it goes into the analytic work where the testing is actually done on the instruments, and somebody have to review and interpret the results. And the results is now released back to the physician, and also you have to manage the specimen into storage or whatever you have to do to get rid of the tubes. So this is like a generic lab workflow. But what you can see here is in any of these phases, the pre-analytic, analytic, or the post-analytic, there is potential for a rework. And when I say potential for a rework, something can happen that you have to say, I have to do this work again. And on the collection side, I have some examples here. The specimen that was collected can be clotted. Somebody not following the instructions on the labels. You can have a leaky container that doesn't allow you to get enough specimen for testing. A whole list of things can happen that can result in a rework. On the analytic side, on the processing side, you can have errors, like I said, with centrifugation. You can have lab accidents within the lab. And in the testing side, you can have issues with erratic results, lab accidents, and sometimes the lab don't even receive the specimen at all. So in this case, you have to have a rework in the process. What you can also see here is the sooner you can catch the problem, in the pre-analytic phase, then you don't have to spend a lot of money. The cost of fixing is not as much as when the error is caught in the post-analytic, because now it's going through the whole process. So if it's a recollection, you call the patient back, you do the collection again. It doesn't cost you a lot as it having to go through the whole process all the way to post-analytic. Now, because it gets to post-analytic, now you spend a tech time, you've spent money on the reagents, so it's going to cost you. So the further down your workflow that an error is detected, the more costly it is. So this is why we're saying that we have to make sure that we have processes in place to, if there's an error, catch the error on time before it gets further down the process. And of course, we said we don't want to see an external failure, because once the results gets released and it gets to the physician, now the result is out there. If it's erroneous, now we have a bigger issue of having to explain to the physician why we had wrong results on the wrong patient. So the better systems that we have in place to catch some of these issues, the better. And the upstream we can catch the process, error in the process is also reduce the cost of fixing it. So now let's look at a simple, generic example of cost of quality for recollected blood specimen. So, like I said, if you look here, we have the process step. We're looking at the pre-analytic, analytic, and the post-analytic. And for each of this work that gets done in the lab, there's going to be a labor cost component and the non-labor cost component. So for this example here, we're saying that the phlebotomist gets paid about $17 an hour. And for each of these recollection, it takes about 0.25 hours, 0.25 hours to do that process. So if you multiply the $17 per hour times the 0.25, so it is costing you a phlebotomist time of $4.25. So that's the labor component on that side. Now, if you look at the supply side, you have the phlebotomist is using materials and supplies, and this is on a higher level. But if you want to go details in specifying what supplies that they use, we know phlebotomists use syringes, tubes, so you can have a whole list of the supplies that are actually used for the error that happened. Then you can, so this year we're just lumping everything into materials and supplies, and we're saying it costs us $2 to do that. And the unit or the quantity used is 1. So if you multiply the 2 times 1, you have a total cost of $2. So for your material and supply cost for this error is $2. And now if I add the $2 if I add my non-labor cost of $2 to the labor cost of $4.25, I have a per unit cost of $6.25. So the pre-analytic side alone, just to go back and do the blood collection or do the recollection, is costing me $6.25. So this one, like I said, it's a very simplistic. If you have more titles involved, sometimes you have to involve somebody from nursing. So this one we're just looking within the lab. But if it depends on the level of calculation that you want to do. If you want to look at, okay, this thing started with a nurse noticing we have an issue. A nurse spent some time to do some investigation before the phlebotomist got to know. So you can add all these into your calculation. So you can add the nurse's labor rate and how long it took the nurse to do the investigation. If you want to say, okay, this got to now central processing supervisor have to spend some time to do investigation. So you can add all these titles and how long it took them to do these calculations. But for the purpose of this presentation, we're just trying to make it simple. You can expand this as much as you want. So if we look at on the analytics side, so we're saying, okay, the lab assistant has a rate of $14 per hour, and it took on the average, it takes that person about 0.1 hours to do that. So the cost for a lab assistant to investigate this error is $1.40. And if they use any supplies, let's say they use a supply and materials that cost $3 times 1 occurrence is $3. So for the lab or the analytics side, it cost us $4.40 to do that. Then if we look at the post-analytic, now we have a technologist involved, higher rate. It took them 0.2 hours to do that. So if you multiply the 2, it's $4. Then you add the non-labor cost of $4 unit of 1 times 4, so it costs us $8 for the post-analytic side. So for this recollection alone, the total cost, if I add the per unit cost of $6.25, 4.4, and $8, I get $18.65. So this is one time if I have to do recollection. So let's make an assumption that this is a metric or quality indicator that you do track, and you run at, let's say, 100 redraws per month. So that is cost of poor quality per month of about $1,865. So you can see right away you're spending close to $2,000 a month just on redraws. So imagine you have other quality indicators that you track. You do the same analysis. So you won't be surprised to start seeing this number going up. And this is money that this is the cost of poor quality that is not desirable, because this is money that is eating up into our margin. Because the higher this number gets, the lower our margin is going to be, because this is adding up into our expense. Because we've already done this work the first time, and now we're going back to do it again. So the more we can do to minimize having to do this work, the better. So we're getting to the end of our presentation here. Like I said, this is a very high level. You can expand this calculation to fit your need, because the intent is not here to give you all the different scenarios that happen, by just the way to calculate it. So like I said, if you want, you have to draw the line of, okay, when do I want to start doing this calculation? When do I want to end? Then you can bring in all the different people that are in, all the different titles that are involved, all the different supplies. The most important is to know what the rate is and how long on the average is spent on fixing that issue. And also knowing the supplies involved. Sometimes it doesn't involve any supplies. So once you calculate per unit cost, then you can multiply that by the number of errors that you typically see, and that kind of gives you a ballpark of how many errors you get. So this is error per month. So if you multiply this by 12, now you can see that this is beginning to be a big number. So this can easily go to $24,000 a year just on recollection. So it's very important that we first make sure that we have processes in place that catches problem. We have we continuously look at our processes and find out ways to reduce errors in our process. So with this, I think we'll open this up for any questions any questions that you have on the line.
Thank you, Mohammed. As you mentioned, we would like to take any questions you have. If you would like to ask a question through the phone line, press *7 to unmute your phone. And then once you have finished asking your question, press *6 to mute your line again. Also, you can submit a question via the chat function on the CenturyLink web application.
Okay, so we have one question here. So somebody is asking, what is the cost of re-stick, which is, I believe, is recollection, in terms of delay in the procedure, supply waste cost? So this is, I think this goes in line with what the last slide that we just looked at. So this is asking for the cost of re-stick. So that's what we just did on the screen. So basically, what you want to do here is knowing exactly who is involved in the recollection, how long it is taking them to do it. You can do per unit and then multiply by how many you have, and also supply waste. Yeah, supply waste, because I'm reusing new supplies to do this. So of course it's a supply waste, and by capturing that you can calculate just like we did on the screen, you have your labor component and you have the non-labor component, which includes your supply. So now I'm reusing the supply again, and I'm also reusing a tax time to do a collection that we should have done it right in the first place. Yeah. So this actually is what we did on the last slide. Okay. There's another second part to the question is so the question is asking, very curious how productivity affects cost. From Six Sigma point of view, less productive means more time it takes to complete the procedure equal less patients seen in a day. How can that be broken down into cost? Very good question. Now we're trying to tie up productivity to cost. So productivity is a measure of an output. So I mean, how much work are we doing per day, per hour? It's a measure of the productivity. But what we have to do with productivity also is we have to balance productivity with quality, because we don't want to set unexpected expectation of productivity. Because once you have you have to make sure that you understand, you have done a capacity analysis of your process, understand what can be done, is it per hour or per day? Because once you start shooting for more production than it can be done by hour, for example, now you're going to have a problem with, you're going to have a problem with quality, because now your techs or your phlebotomists will be rushing through the process. So this is a question of how do you balance productivity with quality, because you don't want, of course, you want to make sure that you have a good throughput of your patients through your system, but at the same time, you don't want that to be competing with having to have a lot of redraws. Because once you just have a blanket productivity of we want to do this many sticks per hour, then what is going to happen is more techs will, they will find a shortcut of doing the work, which will lead to many errors. So it is true that if you have low productivity, it can slow down your throughput, but at the same time, we want to make sure that a countermeasure, which is your quality product, is not suffered, because that is where you feel the cost. So I think this is more like a question of balancing your quality requirements versus your productivity. So every lab have to do an analysis to figure out what is the sweet point. What are my techs comfortable to do?
Okay, we have a question here. If I wanted to focus on process improvement project associated with impact recut testing, should I focus on cost analysis of tech hours or cost analysis of supplies, or both?
Okay, so so I think what this question is asking us is, so now we're trying to do continuous improvement project and also trying to figure out what is the cost impact, right? And this is always recommendable, because that is, most of the time that is how people can quantify, because it's easier to say, okay, this process is costing us this much, and if I do something about it, I can reduce the cost. So it's very good to, quantify your continuous improvement in terms of cost. So the question here is asking, if I try to do that, do I do the cost analysis on the tech only, or do I do cost analysis of supplies, or both? I think if you want to have a good picture, I think you have to do the complete. So because every direct process in the lab has the labor component, which is the tech, and has the non-labor component, which is the supplies, materials and supplies. So I think you should do the cost analysis on both, so at least you can get the whole picture. Because sometimes, sometimes we have some tests that the reagents are very expensive. So if you don't do the cost analysis on the supply side, you will not know that, because you might think your labor cost is expensive, but we have some tests that are very, very, very expensive in terms of materials and supplies. So I would say you should do both so you can capture the whole picture.
Okay, are there any questions on the phone line? Okay, well then I'd like to thank you all for participating in today's phlebotomy webinar. If you do have additional questions, please indicate them on the evaluation that I'll be forwarding to you shortly. Note laboratory credit is extended for this program. Upon finalizing your evaluation, you'll have the option to claim credit and print your certificate. As a reminder, this program was recorded and will be archived on our website in a few weeks. Please visit the education website for more information on upcoming education offerings and list of upcoming phlebotomy webinars. Registration is now open for the 2019 Phlebotomy Conference, May 2nd through 3rd, 2019, at a brand new hotel that's going up here in Rochester, and that will be the Hilton Hotel here in Rochester, Minnesota. We hope that you're able to join us for this live conference. And once again, thank you for joining us today, and have a wonderful afternoon.